This is an important component of the air-launched cruise missile. It is being machined at General Dynamics Convair Division, San Diego, on a machine tool under direct numerical control, DNC for short. It is a significant advancement where the machinist is accessing the database of a central computer directly, without the use of paper nor mylar tape. DNC takes computer-aided design and computer-aided manufacturing to its logical capabilities. It is a human and computer interface system for the direct control of sophisticated machine tools, saving time in design and production, eliminating error and waste, cutting costs, and enabling delivery within stringent deadlines. Here is a finished product, the structural plate for the cruise missile body section extender. It enables the missile to carry more fuel and therefore to fly farther. This is one example of several cruise missile components now being designed and manufactured at Convair under direct numerical control. You also saw this cruise missile body section being milled internally, a process requiring complicated cutting movements and extreme precision, but all in a day's work with DNC. DNC is a key system of the overall CAD/CAM program being developed and implemented by Convair and General Dynamics Western Data Systems Centers to streamline manufacturing processes and, above all, reduce costs. DNC facilitates machine shop operations and reduces manufacturing costs by automating numerical control data management for machine tools. Also, and this is important, it provides automatic collection of machine shop and workflow data in a central computer base for management of the manufacturing process. Let us take a look as to how the DNC system really works. A cruise missile component, such as a body extension plate, has to be designed first. This is done at the interactive graphic workstation. A design engineer receives an assignment to design a particular component. After consulting with various specialists related to the project, he lays out the design by means of the interactive graphic techniques. Obviously, the design engineer has to understand how this particular component interfaces with other components in the body section. But as he works, other specialists in such disciplines as stress analysis, producibility, and manufacturing are going to monitor the developing design and provide input as needed. When the design engineer has established the basic configuration, it is automatically stored in the computer database. There are currently 15 of these graphic workstations, with 38 more planned for installation by the end of 1980. These workstations are being placed in the functional work areas for ready access by the design groups. Plans call for one workstation for every 5 designers, operating 2 work shifts per day, 5 days per week. We know these workstations reduce design time by at least a factor of 2. This WDSC computer complex, located at the Kearney Mesa facility, is the heart of a network of computers and workstations which make DNC possible. Design data is transmitted to the IBM 370 complex and stored here for later retrieval by process planning, numerical control programming, and others. The complex consists of central processing units, communication controllers, online disk storage units, magnetic tape units, and a mass storage facility. All play a vital role in the DNC system. All design workstations are linked to the IBM host by communication line. Design data is stored for transmission on demand to the manufacturing systems, and part programs data is stored for retrieval on demand by the DNC network. Built-in redundancy is assured by means of two DNC computers located at the Lindbergh Field facility, adjacent to the machine shop. Each of these two computers has its own disk device for primary service, but each disk is available to the other computer on a backup basis if needed. Ultimately, each of these DNC computers will handle 40 machine tools. But if either computer should go down for any reason, the other would continue operations for all 80 machines. The structural plate has been designed and the data stored in the computer. Now the machine tool has to be programmed with specific operating instructions, which is done at programming terminals at Lindbergh Field. The part programmer accesses the system and calls up the configuration created by the design engineer. Using symbols from his menu and an electronic pen, he inputs to the computer the desired machine tool cutter path and other pertinent tooling information. Final unit in the DNC system is a computer numerical control located next to the machine itself. In the old method, the machinist had to handle punch paper tape, which could be damaged or soiled, or monarch tape, which could stretch or be affected by environmental changes in the shop. Although it was an advancement at the time, this method of numerical control obviously has its drawbacks. With the DNC method, the machinist accesses a computer database directly by means of alphanumeric keys, and his display gives him instructions in plain English concerning the setup of his machine. After the setup, the machine is guided by part programs stored in the DNC disk device. Benefits of DNC include the elimination of tapes, which must be cataloged, stored, handled, may be damaged, and are expensive to make and replace. The computers provide a real-time status monitoring system to monitor tools, parts, equipment, and labor. This information is readily accessed by all who are affected and concerned with operation and support of the numerical control machining functions. A much improved utilization of equipment under DNC makes it feasible to keep the machine tools operating a high percentage of the time. Of significant importance is a management information system. Management will have visibility into the workload and performance of each machine tool and will control material and schedules accordingly. From terminals in various areas of the plant, managers will have access to the status of tool control, manufacturing and quality control, machine maintenance, and the machine shop. At General Dynamics Convair Division and Western Data Systems Center, we are applying these computer techniques to cruise missile manufacturing to meet tight schedules and to cut costs.